So, uh, first of all, thank you so much for joining. It's 5:30 here, so I just woke up. I need my coffee. Um, it's the second session from where we stopped last time, and we'll try to make it as interactive as possible, and then um, try to move on from there. Okay. We had a task last session. Everyone can see the screen, right?
Yep.
Okay, perfect.
Now we can see.
Perfect. So this is where we stopped, or this is where we started last time. So wait, give me a second. Yeah. So these are different technologies and topics that will be discussed, or we need to know something about all this. We have to understand what artificial intelligence is or digital twin is. Yeah. And we'll go step by step into each topic whenever it is necessary. It's not mandatory, but we will go as new topics comes into discussion. So at the moment we are talking about digital twin, and we also discussed four different aspects of digital twin last time. If everyone, I will just refresh everything so that we get to start properly. So four aspects of digital twin should recognize the elements and dynamics of the product, and we will still stick to the GPS example because it's easy to remember the aspects. Yeah. So when you say should recognize the elements and dynamics of the product, if I take GPS as an example, it means you need to understand that there is a car and car is on the road, and the dynamics is that the car is always moving. Yeah. The geographical point of the car or coordinates are always changing, and any digital twin, in case of GPS, should understand all these elements. Second, there should be information flow on both sides. So the car should be speaking to GPS and the GPS should be speaking to the car. And third, it should facilitate the operation of the product, which means, or the system, which means our goal or the purpose of that system is to get from A to B. And whatever digital twin or whatever GPS is there, it should help that goal to achieve in a better or in the best way possible. So that's what facilitate the operation means. So if we have any component which needs a digital twin or which has a digital twin, then that digital twin should help that product or system to function. Yeah, it's not just like a hard disk, like storing data or something. There should be an interaction and it should support each other. And then the fourth one is we should be able to enable some optimization and or control. So there is this function and we are using digital twin to optimize some parameters or to have some parameters under control. Yeah, they are not two independent entities. They have to work together and one has influence on the other. Yeah, and this is where we stopped last time. And we gave a task just to brainstorm on some product or system to create a digital twin. And I hope someone or probably everyone did some thinking. And if you have some, just a second, because I have people waiting. Chase, Mansoor just joined. Perfect. So we will start with the brainstorming session and where we collect ideas on what we can um, talk about or discuss in the future. Yeah.
Okay. So basically, you want
Perfect.
everyone to drop ideas about what they
Give
thought
me a
about digital twin.
yes. Give me a second. Give me a second. Mansoor, you just joined, right? Can you hear me?
Yes, I can.
Okay. Okay. Just I saw that three people joined right now, so I'm just we just started. This is the first slide we are doing, and I just discussed all the four aspects like in last time, so we haven't missed anything.
Okay.
We'll be discussing these four aspects in the next two sessions, no matter what. The task for last time was to choose a product or system to create a digital twin. Now we will do some brainstorming on this and then try to try to come back again to the slide and discuss each idea in detail, but that will be a very progressive session. Yeah, we are not going to discuss everything in detail. We will come back every single time when we have something, and we will analyze all these ideas in the future or in the coming sessions. Okay, so and did anyone think about any ideas till now, or how do you feel about the topic, deal situation? Vignesh, did you think something? I'm sure you did.
Talking with
Like
turning on video.
is it possible to create a digital twin of the human body? Because uh, we have like a lot of diseases. I believe like everyone has some disease or the other. So is it possible in any way that uh, there's like an interaction between the body and like sensing each and every organ in our system to see like if there is any issues anywhere, and based on that some
Yes,
information like
Yeah.
positive information will be shared
a good one, a
if
good
possible.
one. Good.
Stole my idea, Vignesh. I was actually about to say that, along with the Apple Watch or any kind of watch that tracks data, right? Human body data. That's like watches a very, very basic sensor. But I believe in the industry there are so many sensors that are available now that are being implanted in organs. So there is an interaction also which happens between the body and the the system that tracks this. I think
Yes, you're right. It
that's
is possible to make a digital twin of the human body, and this is going to be the future at some point. There is no question about it.
right.
And probably it would be all done by a single chip going on your arms or something, and that's it. But there are
Yep.
already chips like this, but this is only for storing data or not necessarily collecting data. We'll talk about this later. I had a friend who had a chip in his hand. He's from Netherlands, and
Really?
if you go to any hospital, they can just scan the chip and they will get all the historical information about his. So if he has some implants, if he has some metal something somewhere, and so on. But this was a test experiment, so he had to keep it for 6 months in his hand. I mean,
Oh,
it's like a SIM card. It's as big as a mini SIM card, and you can actually feel it in his skin. You can hold it. So, okay, next one. We will finish the brainstorming in like 2 3 minutes. You just have to shout out ideas, and I will write it down. Whether it's possible or not, it's a different story. I'm just going to write it down and come back in the future sessions, or even today we will come back to these ideas. Okay, we are going to end today's session on this slide. Okay, any more ideas?
how about a car
Car, yes. Next,
with sensors?
any more ideas? Just shout out anything that comes to your mind. It does. We don't have to discuss it. Arun, do you have any idea?
Randomly picking somebody on the spot.
Yeah.
Yeah, I thought of some any products which is newly coming into the market before making it as a real, like the same like of a car. If we do have something resemblance of this, like the automated car, which is before launching into the market, they do make a prototype. So why do you feel like that digital twin?
Yeah, basically the manufacturing industry, right? I
Yeah.
had a use case like that, Vineeth. This is specific to one of the industry, like glass manufacturing industry, where uh, like before actually shipping the product, the customer would need to actually experience the product in their hand, like in a VR AR experience. So any product that is being manufactured, it
Yeah.
needs to be in a digital format before it's getting shipped.
Mm-hmm. That's fine. Murali, do you have any ideas? Did you think about something?
No,
It's
I
okay.
missed your session last part, so I just recapped yesterday. So
Yeah, no problem. You have the whole day today, or during the session. If something comes up, we will write it down here. Okay. Mansoor.
Yeah, I was thinking while you were asking everyone.
how about how about going big? Um, Big in a way that if we can have a digital twin of Earth. I
Of
don't know.
Earth?
It's yeah.
Wow.
It's huge. I know, but we have been tracking atmosphere. We have been tracking weather changes, polar ice
Yeah.
caps, everything, whatever is going on.
Mm-hmm.
We have a trapping. There is enormous data
Mm-hmm.
with the satellites and International Space Station and everything else. If we, I don't know, but maybe a computer algorithm or say anything, we can design a small system with all preset variables and see what happens next.
Mm-hmm. Perfect.
That's a
Perfect.
great example.
Yeah.
One more thing, like airplane for predictive maintenance.
Airplanes. Okay, who else? Who else do we have in this team? Vignesh, you said something, or did you get more ideas?
No, no. I'm able to think about human body alone right now.
Mm-hmm. And Murali is also on the call, right? Yeah. Any ideas?
Was it Jaydev
You
who
already asked Murali. I guess you
Oh,
woke up so early, man. That's why.
no, I'm just scrolling down. I'm just scrolling down the list, and it's getting refreshed every time, and I'm not sure who is I don't know who is Murali and so on. So it's really interesting. I'm waking up slowly. So who else? Gitu and Remya, right?
Yeah, Gitu, Ramya, Manju,
Okay.
Rijo. We have a new person joining from the he's a content writer. I don't know, from a content writing perspective, can we think about a digital twin?
I know I use a particular app which is called Grammarly. I use a free
Grammarly.
subscription. Yeah, it's an interesting thing. It it um, it helps you use correct grammar, correct words. It's much better than the autocorrect mode what you have um, in Word, MS Word. So it predicts sentences. It corrects everything. And in fact, you can send. I mean, it's a whole service industry kind of thing. If somebody wants content writing, you can send it out and all those things. But I think Grammarly knows much more about me from past 2 years
Mm-hmm.
than it gives me statistics every Monday, like how good my writing was
Mm-hmm.
based on my emails or everything else. I don't know. Maybe that person who is content writer, he can let us know. So something
Mm-hmm.
about ideas. Yeah, I mean the way I write and conceive or say um, through my writing, probably Grammarly knows a lot about me.
Perfect. Perfect. I have noted down, and then um, after the session, we'll come back again to gather more ideas and maybe to discuss some of them in detail. Yeah. Okay. Now, yeah, I'm
Hey,
I'm gonna
we need a quick time check. We are already past 20 minutes. I think Zoom allows only 40 minutes of
recording.
data. Yeah,
Okay.
recording or
Okay.
even the session, I guess. Even the meeting is allowed
Last
for
time we
20
went
minutes.
for 1 hour, right?
Yeah, sometimes it gives you extra minutes, but I don't know. It happens every time.
Oh,
I would like
okay.
to add one more. Like, is human psychology possible in digital twin?
Brain.
Like the human brain, yes, yes. I mean, Mantu just showed us the potential of what we can do with that. Let's still write it. It's always good to have ideas, and so that we don't forget. Okay. Now, as JD mentioned, we move forward. Okay. Now, I have my own idea, which is house, and we will do the session on the house. And once we have a digital twin of house, we move on to the next idea. So we will have to do more than one ideas to understand how does a digital twin platform looks like. Yeah, what kind of platform are we looking at, and what kind of technology comes on top of it. Um, so you can see the screen, right? Just let me know every time you get kicked out of the PowerPoint or something. And JD, if my Wi-Fi gets cut off, I will have to restart my laptop, and then it will be 5 minutes lost, and you have to entertain the guys. Yeah.
Okay.
Okay. So we are going to do a digital twin of house, and the most important thing of doing a digital twin is not technology, is not algorithm, is not programming and so on. It's about knowing what we are doing and the purpose behind it. Yeah, it's for every project the same, but in case of digital twin, we call it the blueprint. You first need to have a blueprint of the product or the system that we are going to work on. Let's start with the four aspects. And I have a questions for you. When it comes to blueprint, what do you think is the most important from the first four or from the four aspects here? Which is the most important? Where do we start?
I think
I guess the
it's
first one itself.
behavior. If you, I don't know, if you know what to make a digital twin out of, at least you should know the behavior of it, if not the
Mhm.
elements, because some of the elements may not be clearly visible at the first go, but at least the
Mhm.
behavior of the system should be pretty apparent.
Mhm. Perfect, perfect. Yeah, we start with one because it's necessary to understand the dynamics and so on about the system, the boundaries and so on. And next, what is the most important from the four?
I guess the first one itself.
First one.
Yeah.
Let's
I guess,
let's let's ask ourselves one simple question. There are digital twins already available. Now, if I ask myself the question, okay, why do we have digital twin for such systems and products, and why don't we have digital twin for the others? Which one would be the answer from the four?
Like two-way communication.
Mm-hmm. Any
The
more?
systems will be complex. I mean,
Mm-hmm.
in terms of how it is made of.
Definitely. The more, yeah, it's clear. Digital twin every day gets complex. One of the reasons why we don't have so many digital twin is because it's getting complex. So, it's a step-by-step process. We have to follow all of this. Yeah, that's clear. But the reason why we have digital twin for some system and some product is because we are trying to optimize something. If there is no reason to optimize anything, people really don't look at digital twin. Yeah, and in this world, if there is a we do digital twin only if there is a business requirement. Yeah,
right.
otherwise we could do a digital twin for everything. And most of the companies turn into digital twin because they want to optimize or they want to revolutionize or innovate the way the world works or way their industry is working. So that's one of the reasons. So in case of house, we will start with four. Yeah, we are going to start with defining what we are going to optimize in a house. So when I say a house, we are looking at the building. Okay, building is the product and the system is when human interacts with the building and everything that happens inside the building is all part of the system. And we are going to identify or brainstorm certain parameters which we can optimize in our house or we want to optimize in our house. Okay, and that's where we are going to start. That's the first step of almost finishing the blueprint. So after identifying elements and dynamics and so on, then we need to identify what are we going to optimize. Yeah, let it be any product. The question is, what are we going to optimize? Why are we going to use the digital twin? And we are going to write down all these brainstorming parameters. Here's the parameters are what we are going to optimize. I'll come to the variable side later. Now, our goal for today is to complete this table. Yeah, once we complete this table, we have the basics for the basic requirement list for making the digital twin. Okay, and the goal for today is to complete this in the next 20 minutes, yes, or 23 minutes. And the last 10 minutes we will discuss on a question and answer session. Okay, I'm gonna try something. I'm not sure how it will work out, but I still want to try. So we are like 10 people, I guess, here. Um, give me a second. Everyone can hear me, right?
Yep.
So when I say how to optimize or what we're optimizing, I'm looking at, okay, we have a house and what's happening in the house and what we need to optimize. It's going to be a brainstorming session. And one example is if I say, okay, I want to optimize the use of lights in the house, that's one parameter. And also you can think about, okay, I want to optimize the consumption of water at home. Yeah, these are but very traditional, very straightforward thinking. You can also be creative, think straight and think creative, like think something really crazy as well. Doesn't matter, whatever comes to your mind. What I'm going to do now is, don't be scared. I'm going to split this team into two teams. So everyone who has joined will be split into two rooms, and I won't be in the room. Jerry should be in the room, and I want you guys to discuss in between. So my tip is, don't introduce each other, don't say your name and so on. It's just start the meeting as you know each other for a long time, and discuss what you are going to optimize in the house, and then we'll and come back, and we will continue with the presentation. Okay, it's going to be 4 minutes of discussion. So basically, everyone has to come up with, okay, let's optimize that. Let's optimize this, and so on. You don't have to discuss it. The more you discuss, the more time you lose. The idea is just to shout out your thinking, like a loud thought, and then discuss. Yes, you can a bit, but make sure it's all done in 4 minutes. Okay. JD, Arun Murli, and Remya will be in one room, and Gitu, Mansur, Vignesh will be in the other. Okay? So make sure everyone talks and you share your ideas. And you can also continue a little discussion on it so that more ideas comes out.
So
Okay.
basically, identify the parameters that we need to optimize the house.
Yeah.
Okay.
Okay.
Let's get started.
Everyone would get a request to join. You just have to join, and then you will be in the room. Did it work? Did you guys, were you guys able to join and talk to each other?
Yes. Yeah, we got a dozen of ideas.
Yeah, perfect. I was not sure because of the network and so on. Maybe it's only 4 minutes, and maybe you will take 2 minutes to join, you know. So it worked, right? Both teams had no problems.
No. So shall we paste the things that we discussed in the chat? Or?
Wait.
Vineeth,
Yeah.
I think we have that. Did you actually assign everyone to the breakout rooms? Because I had only 3 people with me.
Yeah, I did. It was 5. It is done automatically, so I didn't want to shuffle it anything. It's done by Zoom automatically to save time. So they,
okay.
yeah, they assigned 3 people to your room, and the rest were to the other.
Oh, got it. Okay.
Yeah.
So hope we have more ideas from the other room.
Yeah. It's okay. We will make it better next time. Yeah.
I don't think we have enough time.
Let's start. What? Just shout out whatever you discussed, and I'm gonna type it here.
Okay. Basically, I think in our we discussed about intelligent lighting, water consumption.
Wait. Lighting.
Intelligent lighting or whatever.
Yeah.
Water consumption optimization.
What is wrong with lighting? Yeah, lighting, water consumption.
Home security for kids.
Home security.
So kids spending like finance spending within the house, like optimizing the whatever financial.
Reducing wastage. It's more like reducing wastage. You know, you buy a lot of things and don't use some of them and throw out. So optimize that.
It's more like not asset management. I would say, let's say stock management or something.
Stock or inventory management, right?
Or inventory management. Right. Stock management.
Space management. Like
space utilization.
Space management. Perfect.
Then we have discussed about activity tracking, like the members of the house.
Activity tracking of which is like physical fitness or physical activity.
Physical activity, yeah.
Physical fitness. What else?
Then it's about this thing. What was that? Energy consumption, total energy consumption.
Yeah.
Household. Then the last one that we discussed in the last 5 seconds, I don't know if it qualifies as mood management or anger management for people.
Perfect.
Easier.
I love it. Energy floor
I think Murli,
space.
you added a like like what was that? Intelligent lighting with anger or whatever it is. Like when the anger and when
Yeah,
people get
yeah.
angry, lighting, it can be controlled using the lighting.
Mm-hmm.
Yeah.
Perfect.
So that
Materials
is
stuff.
advice is from our group.
Wood lighting.
Yeah, I think lighting pretty much matches with everything. Lighting automation will cover that, whether it is
Mm-hmm. Mm-hmm.
relaxing, meditation, focus.
We will get into everything in the session in the coming session. We need to know what we are going to optimize. So the structure of the session is like this. It's very simple. We define what we are optimizing, and then we define what are the data we need to collect to optimize these things, and then we decide what we do with that data, and then we decide how we can influence the user or the system or the product um, to optimize the things that you have mentioned here. Okay, so that's the whole idea of the structure of this session, what we are doing. Not just today, we will focus only on this today because collecting data is very important, and that's what where we have to start. If you don't have data, then we don't have anything to work on. How about for Mansur, it might be relevant. How about heating, ventilation, and so on? So that's air conditioning and so on.
Oh, absolutely. Yes, yes.
Heating and for everybody else, air conditioning is also important. Okay.
It comes under the energy consumption, right? Like
Energy consumption, yes, we can. There are different levels in this, so we can just control energy consumption as a whole, which means you are optimizing the electricity bill at the end of the month for the whole house, or you are trying to. We can be specific because when we are specific, maybe this data might not be. For
right,
example,
right.
I want to reduce the use of television, so the data that I'm collecting probably might be different from the heating.
Yeah.
Parameters. So we will have everything and then we will look into it into detail slowly later. Okay. We don't have to do everything, but we are just getting it. Anything else that we missed out?
No, I think
Vignesh?
along the physical fitness
Yeah.
management, we discussed about the TV time
Okay.
management, TV time or screen time management within the house.
Yeah. Yeah. We the more we discuss, we will already see how we are going to define these parameters. If there are more than multiple data involved in optimizing one of these parameters, then we are already seeing a complex model. Yeah, physical fitness is about, if I say physical fitness is about what you eat, how much you walk, how much TV you watch, then you are already looking at 50 different data points to collect. And then you have to find make sense out of all this 50 data.
Yep.
Yeah. And that's already a complex system, but that's where the future is going. As Mansur already mentioned, if you're going to create a digital twin of Earth, you're looking at more than 50.
Right.
Okay. What else? Did anyone think of bio waste, reducing bio waste?
Yeah.
What's your?
No. The things that we discussed with respect to, like, there are like matching things like electricity, water,
Mm-hmm.
billing system of the house, like insurance and all the billings related to anything and everything that takes place, and temperature
Billings. Okay.
control.
Okay. We
Yeah,
still we write billings.
and yeah, and safety and security of the house.
Mm-hmm.
Then like lighting feature that is already mentioned, and roof and other piping leakage issues and all those things which can be found.
Yeah, water flooding was
Flooding,
what we were thinking.
yeah, water flooding, fire,
Okay.
then
Okay.
doors and windows, lighting, architecture of the house, any issues with respect to that.
That's a
Then
safety in terms of fire and
and
Leakage.
then
water.
like calling the 911 or the police in case of any issues, like in an automated way.
Mm-hmm. Mm-hmm. Okay.
So yeah, these were the things that we had discussed. So.
Okay. That's already good. How about reducing food waste? That's what I meant by bio waste.
Yeah, I wish
Yeah,
that's a good one.
Okay, great. How about noise level?
Yeah, I think that's a good idea.
yeah,
Noise levels.
Noise level in the house. And So these are parameters, but at the same time, we can also try to reduce some of the actions that we are doing. For example, so if somebody says, I want to optimize how I water my interior, or how do you say, the plants that you keep inside or on the balcony. Yeah. I'm just going to write everything so that we have an idea of what we are dealing with when it comes to digital twin.
Greenhouse gas.
No, I
Greenhouse
think
gas.
if you try to manage these parameters separately, right? You also need to consider happiness index of people who are living inside. As a
Yes.
house, it should actually optimize, or it should try to make the people happy, right? So
Yeah.
if
Yeah.
each of these items are optimized, then people may not be happy.
But
So I guess we
how
need
can
to
you
add
judge?
that.
But how can we judge the happiness of the people that
Yeah,
live inside?
so that's the system that has to learn, right? So when you reduce or when you optimize something, is the people inside happy or not? So based on that, it has to adapt, right?
It's a mood management, right? Mood
It's
detection
not
and
exactly mood, but overall, when you try to optimize a parameter, you need to also consider how it affects the people who are there.
Yeah,
You can
you're right.
optimize everything. You can turn off the light entirely and say that, okay, I have zero wastage of energy, right?
Mhm.
So that's not what we want.
Yeah, I
So I
mean,
think all
Yeah,
yeah,
that's
this,
interesting thing, Murli. When you talk about home, it's like
yeah,
everyone's single idea of home is, it's like home sweet home. It's a happy
yeah,
home. No, nobody
correct.
wants to have a sad home, or like, hey, set the home. You talk to Siri and say that, hey, set the home today for a party. That also brings happiness. But nobody
Yeah,
sets the home for anger. So
right.
I mean,
It
it's kind
eventually
of like a,
happens, I guess.
yeah, eventually happens, but I think we can also consider that the happiness index or anything. That's good.
yeah, yeah. Happiness index or happiness index. Yeah, I'm going to write happiness index. It's better than aspect. Um,
alcohol consumption optimization.
alcohol consumption.
Everything feeds into that, JD.
That's going to
Alcohol.
make you very sad, Judy, right?
I know. The happiness index will go down, I guess.
Yeah, yeah. And just to come back to this point of happiness index, yes, you are right. Home is sweet home, and it has to be fulfilling, satisfying, and so on, purposeful. It's all philosophical. That's clear. And what digital twin should help you do is achieve all those things with minimum resource, or not wasting resource. That's the whole idea here. Yeah.
Yeah,
You don't have to be in the dark. At the same time, you don't need the light in every room for you to be happy. You just need the light near you, or where you are, or wherever you are. So this is what optimizing means. It doesn't mean that we are going to minimum resource consumption. It means optimizing. It means what is the optimum level for you to have the kind of life that you want. Yeah.
Right.
What
yeah.
else?
Can we check the cleanliness of the house, like which part of the
Perfect.
house?
Cleanliness,
Fine.
cleanliness. I had on my book about vacuuming schedule and so on, how we can reduce, optimize how often we vacuum, but cleanliness factor is already good.
Yep.
Okay, what else? I also want to write food consumption so that we have a different set of that. On food consumption per head, per house, doesn't matter, per day, per week. We can look into it also later. Yeah, so that's something we can also optimize. What else?
Yeah,
And how much is the
Geetu just.
water? Oh, yeah, go ahead, Mansoor.
I think there was one more suggestion from Geetu. Cooking gas, automated cooker.
Cooking gas consumption. Perfect. So you want to optimize cooking gas automated again?
Automatic cooker, it says. Maybe cooker, or maybe like the cooking stove or something. I don't
Like
know.
monitor the amount that is being used,
Amount
the
of gas
level being used.
used.
Uh-huh.
Yeah, maybe.
We will stick to this, and the more we brainstorm, the more the form and idea, the definition will be more clear for us where we are going. Okay, now we have 40 minutes, you said. We already crossed the 40 minutes, right?
Yeah.
Okay,
So
that's good.
Can we
whatsoever.
like measure like the amount of water consumed by each individual inside the house? Like,
Yes, yes, we can. Why not? We have it here. Water consumption here. It's a question. We will go
no,
into this
that is like with respect to the entire water
entire
usage. But
house.
yeah,
Yes, yes, I
what I'm
understand.
asking is like specific to the like the drinking water, like how much
Uh-huh.
Oh,
is being
that's
consumed every day. Yeah.
Yeah, drinking water. That's perfect. Drinking water per head.
related to the health index.
Per head.
It somehow feels to me that we are arriving at a robot now.
We
One person who is always one person or one robot always in
Yeah.
the home taking care of things, whether it's a software implementation or hardware. It looks like we're
Yep.
asking a robot here.
That's a digital twin, right? It's
we
basically a digital twin of your house.
we will see if it's going to be a robot and how a digital twin could be different from a robot and so on. Okay. And that's the point of the session. We could just, I mean, all these things can be done in one single slide. What's a robot, what's a digital twin, and how does it work, and how does it work, and so on. But it's not fun. We have to define, we need to have an end product at the end of every single second that we are interacting. So it's 10 people talking for 1 hour. That's almost 10 hours. And we need something that's unique about this team. We don't want to take anything standard from the internet or something. So that's what we are doing here, creating something unique, and we will learn together. So that's the whole point behind it. Yeah. So we will see. That's the curious part, interesting part. We will see if it's going to be a robot or if it's going to be something else. Yeah. Or if we will even notice that there is a digital twin and it's helping us. Maybe we will never notice because there are a hell lot of digital twins in the world which we are not aware of, but still we are influenced by it. Yeah, like the weather forecast, like Mansoor mentioned. We look at weather every day. How do you think the weather forecast is made? Because there is a digital twin somewhere which is collecting data and predicting it. Yeah,
Hmm.
it's a robot. It's nothing but it's a robot. It's the program that's telling you, okay, this is the weather for tomorrow, and we take it for granted, or we trust on it. But we don't say, it's a robot talking to us, and it's not criticizing. Don't get me wrong. Unawarely or without knowing, there are already lots of robots or programs which is influencing our life in every second. Yeah.
Yeah.
Facebook, yeah. It's the biggest robot. It's a digital twin of the planet from the humanity point of view. There are 7 billion out of 7 billion, at least 1 billion, I guess. They're already on the Facebook. So if you get data from Facebook, you can really define the happiness index of the world for that
Oh,
day. And Facebook can also influence the happiness index. And that's a perfect example for digital twin. It can also rig elections. It can also rig friendships and so on if Facebook decides. Simple as that. It can teach you. It can make you join a course. It can make you watch a movie. It can do anything it wants. It's already a robot, but we don't recognize. So this could be the future, but let's see how this turns out to be. Okay. Now, we have everything what we require. It's already a vast topic. Now we have 9 more minutes, and I'll tell you what we are going to do in this session and the next session. Um, we need to define the variables for each parameters what we have. This is also going to be a brainstorming session, but we do it together. For example, if I take lighting, then the question is what kind of data I need to collect to optimize lighting. Yeah, what are the variables on which lighting is based on? Let's do a 2-minute brainstorming, and there we will get a better idea of what I'm talking about. So, can someone say on what is the lighting based on? What are the different variables?
I'll start by looking at the time of the day.
Time of the day. Mm-hmm.
Brightness.
Mm-hmm. That's the luminous flux or luminosity or the flux that's currently there, right? That's what we are talking about when you say time of the day and the brightness, right?
brightness is the like I think the time of the day is based on what time of the day it is. We can control the lighting automatically, right?
Yeah. Brightness
Brightness is
changes
in
with the time. Yeah.
It's light intensity, right? What you're mentioning, how much light we have now. Based on that, you need the lighting to function, right?
yeah,
Okay. What else?
energy consumption, total energy consumption.
No,
it's tight, right?
on
If
what
we
variable is the lighting defined? Yeah.
Like
So
sensing whether there is a person inside the
yeah.
room.
So it's either people or head count. I will write head count. So based on the number of people in the house, the lighting of the house varies, right? If there are 4 people in 4 different rooms and so on, then and then as you mentioned, if there is a real person in that room or not. So it's a binary 0-1 version. If it's 0, there is no person, and if it's a 1, yes. And also if there are 10 people, the lighting is going to be more. And if there is only
Area.
one
And
area,
based
Air.
okay,
on the weather, the lighting can be different. Like
okay, perfect. So yes, and it's interesting how we are going. So we collected all variables what on which the lighting is depending on. Yes, so these are the data we need to collect
how
to
will the weather,
optimize lighting.
how will the weather depend on
like
this?
if it is like a
Cloudy, you mean?
rainy season, it's a cloudy, then it can be different. And if it is like very
Oh, got it.
sunny and
Based on the UV index or whatever it is outside,
yeah,
control the lighting
like
inside.
changing the mood of it can change the mood of the person also based on.
How
And
about
JD, if you are having a party, then
yeah, that
definitely you
was
need
a
party lighting
yeah, party lighting or whatever, like
So
or Deepavali lighting.
based on the activity of the people inside.
yeah, so
Yeah,
we
if it
have
is
the
all alcohol consumption, then we need a lesser light. So
yeah. So one of the thing is the number of people in the house, and the other is individual nature of the people. Right?
Right.
We need to know what mood they are in and what kind of theme is going on and so on.
Yeah.
And
Okay.
also every room also matters, right? I mean,
Number of
in the
rooms, you mean?
no,
Or
not number of rooms, nature of the room. So
nature of
Yeah.
the
basically,
room?
in patio, in night we need light, right? So
Yes.
Hmm.
Perfect.
Type of room.
Yeah. So let's look at these things from an engineering point of view. Yeah? So we have lightings, we have variables. Now we cannot. We need to optimize also the data that we are going to collect. So if I say 1, 2, 3, 4, 5, 6, 7, 8, 8 different. It's already 8 different data points or data types for just optimizing light. Now there are some of the things what we can really look at. For example, Mansur or Murali, who mentioned time of the day?
I think I mentioned it.
Okay, so time of the day, it means day, night, and noon or evening and so on. So you want to look what time of the day it is and then optimize the light based on it, right? That's what you
Yeah,
meant, right?
yeah.
Okay.
That can be easily linked with the clock.
Mm-hmm. Mm-hmm. Perfect. And the next one is light intensity, which I mentioned, which basically is doesn't matter what time of the day it is. I'm just measuring the available light at that time, and based on that light, I'm linking it to the life or the human factor in there, and say, okay, this light is not good enough. So there is a minimum level of light already scientifically defined for looking at the monitor or watching a TV and so on. So I'm just measuring it real time and then adjusting on based on that. If there is enough light, and that's it, I don't need more light. If there is no enough light, then I have to get more light in.
That's based on the lumens, right? Or whatever the
Yeah. So the data point in that case will be only real-time collection of what light I have right now, and not linked to anything else. And weather, Vignesh, you mean if it's cloudy outside, there is less light and we will need more light, right?
Yes.
Okay, perfect. Individual nature is depending on the people's nature and what they want to do. And nature of the room is like if it's outdoor, or if it's a balcony, if it's a patio, and so on.
one more
Great.
thing. If we are optimizing, if you are optimizing the total home for energy, particular energy level for a month, right? We can do monthly, or we in the sense the system can do a daily average consumption of energy, right? And control the lighting based on that, or at least alert the house members based on that.
Yes, that's the point. And when you write the algorithm or when we create the digital twin, these are some of the base data which needs to go in. Yeah. So if
Right.
that's a traditional way of doing it. You have a base data, and then your program or whatever is telling you or warning you, it's already going too high. Maybe it's time to control.
Mm.
The other way of doing it is you don't have a base data, life
Mm.
goes on, but this twin lets the life go on at an optimized resources usage. So
Mm.
there is no limit, but if you have 10 people, the house will be still consuming optimal level of energy. Yeah, and not just too much.
Got
Not
it.
lights everywhere. It works only depending on where you are and what you are. So we have 2 more minutes. What we are going to do just before something goes wrong with our session and so on. We will be going into variables of each of this in the next session. Yeah, and we will figure out what are the common variables, what are the common data which are linked to one another. Yeah,
Yeah.
so that we can create a digital twin with minimum data points. Yeah, for
Vinny,
example, yeah.
I don't feel, sorry to interrupt, but why don't we circulate this list to the
Yep,
group
Yeah,
and at
yeah, for
least
sure,
it's a good idea.
yeah.
for sure. And
We
we will
for the next.
start with this next week as well. But I want to complete the whole structure so that everyone knows why we are doing this and where we are going with this. Okay, I will
Right.
explain the next two steps so that nobody is lost. So we will go into every variable and we will find out the minimum, just like doing a business. We will find out the minimum data required to optimize all these parameters. And based on that data, we will set up the digital twin. Now, what is the logical step when we define all the data that we need to collect? What would be the next logical step when we define, okay, I need to know the head count every time. I need to know the intensity of light every time. I need to know the nature of the room and so on. What would be the next logical step? Can someone say?
Create
The
the
crosstalk.
design the house or something with the data that we have.
Okay, somebody else? Someone else
Um,
was, yeah.
in interacting the interaction between these variables,
Okay, perfect.
are prioritizing which is more important. For example, hitting the goal, monthly energy used, or light intensity, or depending on rooms, whatever. We
Perfect.
can
Very well.
prioritize.
Yeah, yeah. Vignesh, you are thinking too much. Do you have something to say?
No, no, I'm not getting it actually.
Yeah, yeah, perfect. Just yeah. Every point is right, but we have to sequence it in the right structure, or we have to structure it in the right sequence. So let's think once more. Logical. So I need to know the head count, and I need to know what time of the day it is. We already answered all these stuffs, yeah. And I need to know what weather it is, and I need to know the light intensity. What would be the next step? Logically, if I
To
want
sense
to,
all these.
exactly, we need technologies and tools to measure all this. And when we measure all this, then we can integrate, then we have the design, then we have um, what do you say, the blueprint that I mentioned. Yeah, there are
Like
different models in different stages. So once you have the blueprint, you know what you are measuring and how you are going to measure it. And once you have all the data, it's called a data model or a semantic model. Yeah. And once you have all the data and semantic model, then you finally move into the programming and so on, and then end this digital twin. So the next logical move for us is, it's going to be really interesting and fun. We are going, let's say a head count. I'm going to take head count and I'm going to put it here. So this is a morphology diagram, and I'll explain. So we'll take 2 or 3 minutes more before closing this session, okay? Everyone, I hope everyone has 2-3 minutes more. So what we are going to do is we decided what a head count is. And once I finish it, you will know what a morphology diagram is. Now the question is, how am I going to measure the head count? What are the different technologies available to measure the head counts? Let's do a 1 minute brainstorming in this session so that everyone knows what a morphology diagram is. So how can we know the head count in a house?
A motion sensor.
Okay, motion sensors. What else?
manually inputting the number of people, like if you are using a system or whatever.
Manual input. Let's stay out of the manual input at the moment. I will consider it as an option, but let's consider everything
Based on
else.
the oxygen level in the room. Something
Yeah.
with respect to that.
Yeah.
Okay, oxygen level.
A smart camera.
Yeah.
Yep. Video
Visual,
input.
right? Visual.
Yeah.
Yep.
Visual as camera. Okay. Face recognition basically. Because
Yeah.
we also, if you look at all the variables and the logic and the data we need to collect, you can already link. We need to know how many people are in the house, and we also need to know who all are in the house. All this pattern will come out of the previous slide. So just like anger management, happiness index, alcohol consumption, food consumption, food waste, everything is linked to the head count and also the people who are in the house. So we need to also know who is in the house, right? So it's visual, camera, face recognition, or whatever. What else? What else? How we can know who is in the house and how many people are in the house?
Noise, like
Speech
your voice.
recognition, right?
Yeah.
And it's interesting because in speech, this I'm making it very general now, and technically you can really be specific on technologies here. So I can also write Alexa. Yeah, I'm gonna use Alexa to know who is in the house. I'm
Yeah.
going to use my something. I am going to use my laptop or my TV, which might already have a camera to sense who is in the house. Yeah.
Right.
What else?
Maybe heat, depending
Heat.
on
Heat
Yeah.
how
sensors,
much of
right?
heat sensors.
Heat sensors. What else? Like in the Predator movie, right?
Gitu says IR sensor. What is IR?
Infrared. That's what's happening in the heat sensors. That's what's happening in the Predator movie. Everyone has seen the Predator movie, right? You see how the Predator is watching everyone in just like heat sensors. So this is what IR sensors are. What else? We can also measure them by physical coordinates, yeah, which means if our floor has a grid or is like acting a coordinate, then you can measure how many people are in the house by whatever means. So it's physical coordinates, let's say.
That's like a motion sensor, right?
It
A
could be
camera.
motion sensor, it could be just a static sensor. It doesn't have to have the dynamic nature to it. So I hope you already get an idea of what I'm doing. So we have the variable head count, and then you have several ideas here. Usually in morphology diagram, you pick the best 4 or best 3, and not like 6 or 7. I kind of put everything here because we as a team can realize how wide we are thinking. Yeah. Now imagine brainstorming for all the topics that we mentioned in the previous slide. I mean, this is how startups, yeah, the small startups comes up with new technologies and new programs and new tools and so on, because they are solving each issues what they figure out using this method. Now I'm gonna place this. Just give me a second.
Rijo says water consumption.
Yeah, yeah. Water consumption. We will add water consumption uh, in the variable of water consumption. We have one parameter to reduce there, so we will use it there. Okay. Okay, Rijo. I have not forgotten the idea. So let me finish today's session with explaining what we are going to do with morphology diagram. That this is the most interesting part. Now, come on, come on. This is the most interesting part. So we already have some variables defined, and we already know what kind of technology we are going to use, right? Now we do this for all, wait, for all, so let's say, yeah, for all parameters, yeah, for head count we have for whatever parameters we are going to do, let's say XXX, AAA, and so on. And for each we will have one or three or four, I don't know. We will figure it out later in the next sessions. Oy. and so on. Now, when we have all these parameters, what we are going to do is we are going to figure out what's the best way of finding these variables or parameters. Yeah. And then what we do is we link each, we find the possibility. For example, if I decide I'm going to use a visual camera, that's the best way to know the head count, then I give this a point. Let's say this would be my first solution, and then I look into the next one. That's XXX, and then I find that solution 2 is better. Yeah, then I'm going to link it to solution 2. And then I go into the next variable and I figure out, okay, solution 4 is better. Yeah, this is the most optimized or the easiest or the cheapest, whatever we define. Yeah. And then we look into the next parameter and then we pick up the next best solution. So once the morphology diagram is complete, you will see what kind of technologies we are going to use for capturing the data and what kind of technologies will play a role in our digital twin. Yeah, so this line is one scenario of how we are going to create a digital twin. It could also be like this, 1, 2, 3, and then there is another option. Okay, we could also go with something like this. So that's a different scenario altogether. So from a morphology diagram, you are getting like a tens of different solutions. Yeah. So if I'm going to make a car, to explain morphology diagram, if I'm going to make a car, I would write engine here. Yeah. And then I'm going to define all the options. So diesel, petrol, and electric, right? And I can always pick one of the engines here. And then what do I link it with? What kind of sports model it's going to be? Is it going to be a luxury? It's going to be a sport model or whatever. And then you get a different combination of everything. And then you decide what meets your business requirement and you're going to take it. So that's the scope of morphology diagram. Yeah, just that everyone knows. So I would suggest we still focus on slide number 5 and try to fill this in the next session so that people who joins in the next session also gets to be in the team before we start with the technological stuff. Yeah, so everyone gets a slide. You just have to go through it, and we stick to maximum four different variables on how we can reduce water consumption. Most of them are going to be repetitive. Don't worry about it. Okay. And then we will go into morphology diagram and figure out what kind of technology we are going to use. Is it going to be a smart camera? Is it going to be Alexa? Is it going to be our TV? Is it going to be fingerprint scanning or retina scanner or whatever? Or the phones. We could use our phones as sensor. Yeah. So this is the one-day workshop, if you ask me. If you're going to start a one-day workshop on this topic, and if you are a startup, we will have like 1,000 ideas already, which is not in the market. That's the funny part. Okay. This is what we are going to do in the next few sessions. Okay. Let's summarize. And what I'm going to do with this is I'm just going to make different colors or make orange about the tools and topics that we discussed today. Can someone say what all topics did we talk about from this list?
Computer vision.
I would give it, we didn't really talk much about computer vision, but where we spend more than 5 minutes. Let's take it as a criteria. On which topics did we spend more than 5 minutes?
Artificial intelligence.
Did someone say that word artificial intelligence more than 2 times?
No.
Just read through everything and what seems familiar.
Morphology diagram.
Perfect. Morphology diagram is something we talked about, and we will talk about it in the next meetings.
Requirements list.
Requirements list. Perfect. Anything else?
Object recognition.
Yeah, we did talk about, we just talked about the heading.
And IoT also.
IoT.
We didn't discuss anything about IoT, but we started. So everything in yellow is we initiated the discussion. Everything in orange is we went more than 5 minutes deep.
And the goal is that after every session we do this, and we need to get to the green part. Yeah, when something is completely done, then we move it to the green. Okay, this is the goal. This is how I prefer to finish off these sessions. Okay. Sorry for taking 10 minutes long because I wanted to have a proper closure. Otherwise, it's half done. Any questions and anything that you would like to change on the sessions and so on? Any feedback?
No, this is great.
I think it's
Okay.
going good.
It was really good. Thanks, Vineeth.
Perfect. Thank you so much. Any changes, just let me know. Any feedback, just let me know. So I will send the slides. Hopefully in 1 or 2 hours you might get because I'm going back to sleep. and we will work on this. Yeah. Let's not spend so much time, but in the next session we will spend 20 minutes on this. So if anybody has printer, what my suggestion is, if anybody has printer at home, just print this paper and write it with pen on top of it. Otherwise, we are not going to do it. Yeah, leave it on the dining table or on the couch or on the sofa or wherever, and then you are one day going to finish it. And then we come back with the prepared note. Okay. So this is important. Without this, we cannot move forward. We do this, we do the morphology, and then it's going to be all team building workshop in the next meeting. Yeah. JD, up to you.
Yeah, thanks, Vineeth. This was an awesome session. Like, loved the interactive part of it.
Then everyone have a nice weekend.
Yeah, you too.
Yeah, great.
Thanks.
Happy holidays to everyone. Take care.
Thank
Oh
you.
yeah, we'll have the next session in 2 weeks. Okay.
Oh, before New Year? Really?
On New Year, maybe. Yeah, we'll see. We'll see. New Year's Eve, I guess.
JD, come on, don't kill the party.
All right, I'll share it in the group.
Yeah.
All right. Thanks everyone.
Thank you, Vineeth.
Thank you.
Thank you,
Thanks.
everyone.
Bye.
Bye-bye.
Thank you all.